Hello and welcome back to Math with Mrs. Becker. Today in Pre-Calculus, we are going to start Chapter 3, Section 2, where we really take a look at the graphs of functions. It says a graph may be used to define a function or a relation. Suppose that f is a function and it's defined by a graph in the coordinate plane. If the point x, y is on the graph of f, then y is the output produced by the input x, or y equals whatever the function is when you fill in an x. Okay, now I know sometimes when you read text from a math book, and that's what that just was, it can be a little bit confusing. Okay, so let me just go ahead and break this down. What's going to happen is we are going to have a graph within a coordinate plane. Okay, now if you have a point x, y, remember, y is called the output. And just as a reminder, y always tells you if you are going up or down from the x-axis. X is the input. Now, the input always tells you how you travel to the left or the right of the y-axis. So again, ordered pairs, input is x, output is y. The ordered pairs are on the graph, which is going to be in the coordinate plane. Now, here's one of the first things that you're going to see when you practice your exercises from 3.2. Now, keep in mind, we have this function notation. It's f of x. What they're saying is f of x equals y. So here, when they give you a function within the coordinate plane and they want you to find the following, they want you to find the y value. They're telling you that this is x. So here, my ordered pair is 0. What they want you to do is find y. So if x is 0, and I know that because that's in the notation, the x value, the 0 tells you if you go left or right. I don't go left or right. So in order to touch the graph, I would have to go up 1, 2, 3, 4, 5, 6, 7. So this equals 7. And all that means is that you have an ordered pair on this function within the coordinate plane. You have an ordered pair located at 0, 7. So this time it's a 3. So this means that the x value is a 3. What is the y value? If I go to the right 1, 2, 3, in order to touch the graph, I don't go up or down. I stay right at 0. So f of 3 equals 0. Okay, so this notation, whatever's in the parentheses, that's the x for the ordered pair. What they're asking for is the y. So you go on the graph. The x value tells you left or right. So here when it's a 0, I did not go left or right. In order to touch the graph, I went up 7. So that's the value. Here it's 3. It's positive, so I went to the right 3. I did not have to travel up or down. I stayed right at 0. Okay, now the domain. The domain are your x values. Which x values are defined? Now notice we have an ending point right here. So if I am looking at just this piece, the x values, negative 1, 2, 3, 4, 5, 6, 7, 8. This is negative 8. So remember that interval notation? The negative 8 is a filled-in circle, so that's a squared bracket. So it starts at negative 8 and it goes all the way to 1, 2. The 2 is an open circle, so that's part of the domain. Part of the x values start at negative 8. It includes the negative 8 because it's a filled-in circle, and includes all the values up until 2. 2 is an open circle, that's why it's rounded. But now you guys, I have a second piece. The second piece starts at 1, 2. So it starts at 2. It's an open circle, so that's why it's rounded. And it goes all the way to, this is 5, 6, 7. And this is included. So that's your domain. What x values are included. Notice I did have to have 2 pieces because both of the 2's are open circles. So they are not included within the domain. Okay, so you can't, if I was looking at a piecewise function, and that's something that we're going to study further. If I'm looking at a piecewise function, there would be no place to put that 2 because it's not included in either piece. Now the range. Remember, the range are the y values. So again, just like x, we look smallest to biggest, you look left to right. Range, you look smallest to biggest, you look down to up. So the smallest value that I see, this is negative 5, 6, 7, 8, 9. So negative 9, it's a filled-in circle, so that's the smallest that I see. The highest, and notice that wherever this does not include the y values. It's covered here. So I can go from the bottom, everything is covered all the way up to, this is 1, 2, 3, 4, 5, 6, 7, 8. And this 8 is a filled in circle. So your y values are anything from -9 to +8. So again, domain or x values, you go left to right. Range or y values, you go down to up. You can do this interval notation. Let's say that you're somebody who really does not like interval notation. You could always write it as inequalities. The smallest value was -9. Y, because it's the range, it went up to and including +8. These two things mean the same thing. Okay, so notice I did interval notation while we did the notes. It is totally okay if you do inequalities, whichever one you're most comfortable with. Okay, when we talk about a function, what a function means is that each x value can occur only one time. So when we are looking at a graph and trying to determine if something is a function, we have to do a test that is called the vertical line test. Now remember, vertical lines run up and down. So the way that the vertical line test works is you draw vertical lines throughout the function. If your vertical lines touch the function at only one place, then you know that it's a function. But if you have a vertical line that ever touches that graph at more than one location, then no, it does not pass the vertical line test. So no, it is not a function. So if I go ahead here and I draw vertical lines, notice this is not a function. The reason why is because every darn vertical line touches that graph at two places. So no, that is not a function. If it is a function, every single vertical line can touch at only one spot. Now, if I go here, touches once, touches once, touches once, touches once. Yes, this is a function. Okay, so a reminder, a function means every x value occurs only one time. To check to see if a graph is a function, you use the vertical line test. Every vertical line can touch the function at only one spot. If it does, like we had here, yes, that function, or yes, that graph represents a function. If it does not, if your vertical lines ever touch more than one spot, no, that graph does not represent a function. Okay, next idea. If you really want to have a discussion about a graph, or maybe you are comparing two graphs, it's really important that you know various things. So you have to make sure that you understand what x and y intercepts are. What are intervals where the graph is increasing or decreasing? Where do you have what are called extreme points, local minimum and maximums, okay? Where do you have the graph? Where is it concave up and concave down? I believe that's the only idea today that should be new for you. And then that pairs with what's called a point of inflection, okay? So x-intercepts. X-intercepts are your location where y equals 0. It is the location, and you might have more than one, okay? It is the location or locations where the graph crosses or touches, because sometimes your graph might not cross the line, it might touch the line. Remember we had those multiplicities back in Algebra 2, where if you had an even multiplicity for a 0, it didn't cross the x-axis, it touched it and bounced back. So when you're looking at x-intercepts, you have to keep in mind, sometimes it will cross, sometimes it will touch the x-axis. Okay, so if I have a graph, and let's say it's something like this, we would actually have 3 x-intercepts. This would be an x-intercept, this would be an x-intercept, this would be an x-intercept, okay? A y-intercept, at that location, your x value is 0 because you are not traveling to the left or the right, you're staying right there on the y-axis. So this is where your graph crosses or touches the y-axis. And remember, the y-axis runs up or down. So let's just say this time I have a line. Your y-intercept would be located right there. That's where your line crosses the y-axis. Now, intervals of increasing and decreasing. You have to remember you always read a graph left to right. It is the exact same thing as if you are reading a book, okay? So let's say that I have a graph like this. 1, 2, 1, 2, 1, 2. I'm just going to keep this pretty easy for us, okay? Let's say that my graph goes like this. It's going to be here. It's going to go down and stop right here, okay? So what you're looking for are intervals where as you're reading the graph goes down or it goes back up, okay? So if I have an arrow going to the left, what that means is that this graph continues forever and ever. So if I am coming from the left and I'm going downwards, 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 downwards till it hits this point right here. So from negative infinity all the way to, you have to use the x value. And again, I just kind of drew this so it didn't end up perfect, but let's say it's like negative 1.25. So this interval going from negative infinity all the way to the x value of negative 1.25, the graph is decreasing because at that point, the y values are going down, 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 down. It hits this point. So where one interval ends, the next interval starts. So at starting at negative 1.25, the graph goes up, 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 up until it hits this point. Now this point is located at the x value 1, I'm going to go like 1.8. And again, if it's not an exact intersection, you're just kind of estimating where that would be. But notice I'm using the x values. From negative 1.25, it's going up, 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 till it hits this point. This point, the x value is 1, not quite to the 2. That's where your graph is increasing. Okay, now from here, notice this is a point. That means that it actually stops here. There's not an arrow. It's not going all the way to infinity. This is a stopping point. So starting at 1.8, the graph is going down, 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 down to 2. So that is decreasing. So that's what that means. So from negative infinity to negative 1.25, it's going down. From negative 1.25 to positive 1.28, the graph is going upwards. Then from 1.8 to 2, the graph is going downward, making sure you're going left to right. Intervals, that's why you see interval notation. Other things to make sure that you're careful of. Where one interval ends, that's where the other interval starts. Where this interval ends, that's where this interval starts. Notice they're always rounded when you're doing intervals of increasing and decreasing. Okay, maximums and minimums. Now that's the location where you have maximums and minimum points. So anywhere where you're switching from increasing to decreasing or decreasing to increasing, you're going to have a maximum or a minimum point. It's called relative because it doesn't necessarily have to be the largest value or the smallest value in the whole graph. It's just the largest or smallest value in comparison to what is around it. So for example, this is a minimum because when you compare it to what's around it, this is the lowest point. It's also the point where it's going from decreasing, it switched to increasing. So that's what a relative minimum is. This is a relative maximum. So here I was going up, 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 up. I hit this point and then I went down. So this is the exact point where we switched from increasing to decreasing. So we have a minimum, and again, sometimes you'll have to kind of estimate where that point is. I go to the left, like negative 1.25, the y value down 2. So that is a minimum point. A maximum point, I go to the right, 1.8 is where we estimated that would be. I go up 1, 2, and let's just say that this is like 2.8. That's a maximum. Okay, so again, we are just looking and trying to figure out where do you have those high points and those low points. It's possible to have more than one minimum. It's possible to have more than one maximum. Just the example that I drew, we happen to have one of each. Now, this is something that's new. Now, intervals of concavity, intervals. So again, it's that interval notation that we have learned this year. Concavity is the way that the curve bends. Is your curve bending upwards? That's called concave up. Is your curve bending downwards? That's called concave down. So when you look at a point, you want to say at that point, is the curve bending upwards, concave up, or is the curve bending downwards, concave down? Okay, so here's visuals of what that would look like. Concave up, concave down, bends down. Now, if I have something like this, so let's go back to this graph. Notice this is curving, curving, curving upwards till about right here. Then, now check this out, you guys. Now it's curving downwards, going down, 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 down. So this point right here, the point where it switches from curving upwards to curving downwards, that's an inflection point. That is the point where the graph switches from concave up to down, or vice versa, meaning if it was concave down, then it's concave up. So if I'm doing concavity for this, okay, it's curving upwards, so it's called concave up. This is an arrow. So negative infinity all the way to the left, and it curved upwards until it hit 0. So that's called concave up. Then starting at 0, now it's concave down all the way to 2, but this is an ending point. So 0 to 2, it's concave down because the graph is curving down. Your inflection point, the exact ordered pair where it switched from curving up to curving down, was 0, 0. Okay, so we're going to go ahead and we're going to take this graph and we're going to do all of this, okay? We're just going to make sure that we understand everything. When you are doing the assignment today, sometimes they give you a graph and they might just ask you for like one question. They'll say, hey, do you have any maximums or minimums? Or find the intervals of increasing or decreasing. You won't always have to do all of the things, so please make sure that you read the directions. There are times where rather than giving you an actual image of the graph, they will give you the equation or the function. What you'll need to do then is go into desmos.com to graph it and be able to find all this stuff, okay? So just a heads up, there are a few questions where you'll be using Desmos instead of just being given the graph. Okay, so if I have this, and first thing that they asked us was x-intercepts. X-intercepts are where your graph crosses the x or y, or your x-intercepts are where your graph crosses the x-axis. So that happens at x equals, to the left, 1, 2, 3. So like negative, do you see where it's in between, like negative 3 and negative 4? So I'm going to say I have an x-intercept at x equals negative 3.5. X equals 0, it touches the x-axis. And x equals in between the 3 and the 4, so I'm going to say 3.5. So x-intercepts, where does the graph cross the x-axis? Y-intercepts, where does the graph cross the y-axis? At one spot, y equals 0. And it's okay that 0, 0 is both an x and a y-intercept because check this out. It crosses the x and it crosses the y, so it should be listed as both. Next thing we talked about were intervals of increasing and decreasing. You always go left to right. So here, this is an arrow going to the left. So negative infinity. Notice the graph is going up, 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 till it hits here. The x value, where it hits there, is negative 2. So going left to right, that is increasing because it is going up. Now starting at negative 2, remember where one interval ends, the next one begins. Now it's going down, it's like a slide, all the way down to here, and at that location, the x value is a 2. So it's decreasing. Now at 2, it's going up, 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 up. That's an arrow, so it's going to positive infinity because the arrow is going to the right side of the graph, increasing. So the graph goes up, then it goes down, then it goes up. Now maximums and minimums. Here is the highest point. It's this point where it switches from increasing to decreasing. So I have a maximum at negative 2, positive 16. I have a minimum where it switched from decreasing to increasing right here, positive 2, negative 16. Now what we have is concave up and concave down. Notice that this curve, as you go left to right, it's bending downwards until it gets to like right here. It's bending downwards, and now it's bending upwards. So intervals, negative infinity, because that's on the left side, it bends downwards. Your graph is totally bending downwards until it gets to that 0. So that is called concave down because it curves downwards. Now starting at 0, again, where one interval ends, the other interval begins. Starting at 0, the graph is bending upwards all the way to infinity because it's an arrow. There's no ending to this graph. It's going to continue this pattern forever. So that is concave up. Now your inflection point, that is the exact point where it switched from concave down to concave up. My inflection point is at 0, 0. That's where this really isn't bending down or bending up. This is the exact point where it's switched. So being able to do all of this, you guys, that is awesome. Like you can look at this graph and tell all those things, x-intercepts, y-intercepts, intervals of increasing and decreasing, maximum points, minimum points, concave up, concave down, and if that concavity switches at all, you have an inflection point. So this is what 3.2 part 1 is. They really just want you to get used to examining graphs. So there are 34 questions total. Again, a lot of them are just going to ask you one thing. Okay, so don't worry, you're not doing this much stuff. There's a few, actually quite a few questions where what you're doing is the vertical line test. They're going to give you a graph and they will say, is this a function? So all you have to do is draw vertical lines. If every vertical line touches the function or the graph at one point, if every vertical line only touches at one point, yes, it's a function. If you have any vertical lines that ever touch more than once, then no, it's not a function. Okay, so again, don't panic that you see that there's 34 questions. A lot of them are going to go very, very quickly. All right, I hope you guys had a great time looking at the first part of 3.2, and I'll talk to you soon.